Hey. Today we're going to talk about domain and range of exponential functions. Your favorite topic. Domain and range. Okay? The exponential function f of t is equal to 500 times 1.025 to the power of t represents the investment of $500 at a rate of 2.5% for t years. What would the domain and range be for this function? Ooh. Well, let's write some notes. Let's start right here. Note. Okay? And I'm going to move this up so that we can see it. Note. Do y'all know what this means? Because this function is within a real world context. The x values domain cannot be less than 0. The initial value of 500 represents the y-intercept which will impact the range of the function. Okay? So let's talk about this a little bit more. Y'all done writing that?
Yes, ma'am.
Okay. I'm going to draw a coordinate grid up here. And we know that the initial value, and this is an investment, correct? So is this a growth or a decay situation?
Growth.
So it's an increasing situation, correct?
Correct.
And it's going to start up here at where y is 500 because that's your initial value, that is your y-intercept, okay? And that then means that it is going to only go up. Do we all agree with that?
Yes.
Okay? So when we look at the domain of this function, the domain is going to be on your x-axis, right? Where does the domain start?
The domain?
Mm-hmm.
0.
At 0, doesn't it? And it's only going to go from 0 and get bigger, isn't it?
Yes, ma'am.
So we can safely say that our domain, which is our x, is going to be what?
Greater than 0.
Greater than or equal to 0. Do you agree with that statement? Okay? So, well, there's only one that has that, isn't there?
Yes.
Okay? Well, let's explain why the range is what it is. The range is going to be, of course, on your y-axis. Okay? That is your range. So where does it start? And because it's increasing, it's going to have to be greater than 500. So that is your y, which is your f of t, correct?
Yes, ma'am.
Is going to be greater than or equal to 500. So the only one that works is
D.
D. Okay? It's not so bad as you thought, right?
No, ma'am.
Okay, we're going to do a lot of writing down here on the bottom. And I'm going to do a lot of writing, and then I hope that as we work some problems, it's going to help explain some of this writing. Why are there restrictions on the range of exponential functions? Okay? Although parent function of an exponential function, although the parent function of this is not going to make sense, in the parent function of the exponential function, that sounds better. In the parent function, the domain in the parent function of the exponential function, the domain will be the set of all real numbers. Okay? That is in your parent function. Okay? The y values are restricted.
What we do if we're out of room?
You're going to make room. Okay? By the function based on the initial value of the function. So what I've basically said here is if you have a parent function, which is, we're going to revisit that in just a minute, what that equation looks like. Your domain will be the set of all real numbers. If you have a specific situation, a real life situation, then that domain may be restricted, okay, as it was here, because we had an initial value where it was 0, okay, because the range was 500, all right? But when you have a parent function, the domain is always going to be the set of real numbers. The range will always be restricted, all right, based on where the graph of your line, where that initial value is, where it crosses your y-intercept, okay? Now, if you have a growth situation, it'll obviously be that number or larger. If you had a decay situation, it would be that number or smaller for your range. And that's what we're going to talk about back down here. How are the ranges similar or different for growth and decay? Similar because both will have restrictions. And you'll understand this term in just a moment a little better. Growth, the range starts with smaller number and gets larger. In decay, the range starts with larger number and gets smaller. Right? So let's turn the page. Everybody caught up? Okay. Okay, it is recording. Okay. In 1995, there were 85 rabbits in Central Park. That's not very many, is it?
No.
The population increased by 12% each year. This relationship can be represented by the function f of x is equal to 85 times 1.12 to the power of x. What would be the appropriate domain and range for this problem situation? What? Okay, well, I can identify the range very easily. The range has to be what? Your initial value is how much?
85.
It has to be greater than or equal to 85. That's correct. So, which one has that? Let's see. D does also, doesn't it? Okay, so we know it's going to be B or D. Okay. Now, am I going to be in a real life situation? Am I going to end up with negative? No. So my domain has to be what? Greater than or equal to 0. So that means it has to be B. Okay? Number 2, you receive $250 for your birthday and decide to invest into a savings account that pays you 5%. This function can be modeled by f of x is equal to 250 times 1.05 to the power of x. What would you expect the range of this function? So we're looking for f of x, which is the y value, which is the range. Do we have a restriction? Yes, because it has to start where? Now, would it include 250?
Yes.
Okay, so it's going to have to be greater or smaller. Are we increasing?
Greater.
We are increasing. So greater than or equal to 250, and that answer is F. Okay, this is the situation where you're dealing with a parent function. Okay, all you're given is a graph. And you're given a graph, and it's asking for the domain and the range of the graph. So you know that your domain is right here. That's your x. Okay? Now, you've got arrows going out this way, and you've got an arrow going this way, which means it's going to continue to rise. Do you agree? Okay. So your domain is going to include what? All real numbers, because it's going to include everything going this way and everything going this way. So we know that it cannot be B and it cannot be D. Okay? So let's look at our range. This is a parent function. Is it ever going to cross X?
No, so it has to be C because it's greater than 0.
That's correct. It's never gonna cross that x-axis. Okay? And so it's going to be y is greater than 0. If I asked you for your asymptote, and we're going to get more into those, your asymptote here is y equals 0, because that is the line, it's this imaginary line that exponential will never ever cross. Okay? So, and we're going to go into that some more. I've asked high school what they're using to teach that, because I don't like what I have found. Exponentials used to be in Algebra 2, not Algebra 1. They recently came down to Algebra 1. And so the material out there tends to include vertical and horizontal, where we only really have to deal with horizontal. And so I've been trying to work on some information, but they haven't gotten back to me because I don't think they know what they're doing yet either. All right, let's flip the page. Okay. All right, this is where I want to talk about, before we move on, I want to talk about an exponential parent function and what it all means. Okay? This is the parent function of an exponential. It is a times b to the power of x. All right? A is always your initial value. It can be called your initial investment. It's your starting point. It's something along those lines. That is what A represents in the parent function. This is the parent form of an exponential. And we've done this before. Function. Okay? All right? An equation would just be y equals a times b to the power of x. That's the parent form of the exponential equation. All right? This b, yesterday when we were doing growth and decay, that b is represented by 1 plus or minus the rate. Okay? And that b is your constant ratio. Do you remember when we did tables and we took the one we put the one in the tables, we took our y values and we put like a y2 over a y1, and that was our ratio. And as long as in the table we could make each one be the same ratio, then we knew it was an exponential function. Okay, so this is used as multiplicative factor. Okay. So if Sam is investing $4,000 at a rate of 8.5% each year, he used the following formula to help determine the value of his investment over time. See, this part right here is representing your B. This is representing your A in your formula, and that is to the power of time, right? That would be your X. Okay? So, and it's not a big B. I don't know why I wrote it that way. So it's a little b because you all know big B represents something different. Okay? So what does the P represent in the formula? Constant rate of change, the constant ratio of growth, the initial amount of investment is correct. Okay? So we're going to be looking at the different parts of this equation and identifying it. One thing you need to know, and please write this up here, the constant rate of change is different than a constant ratio. And a constant rate of change represents a linear function. In other words, if y changes as x or x changes as y, that's different than a constant ratio. That's a constant rate of change. In other words, I get $5 for every hour. Okay, I get $5 for one, $10 for two. Okay, that is a y varies as x. Okay, this is different. How is a constant rate of change different than a constant ratio? Well, the constant ratio represents a multiplicative relationship. An exponential function. In other words, yes, it multiplies upon itself, doesn't it? How does the initial value relate to the y-intercept of the graph? Well, the initial value is the y-intercept because, think about it, when x is equal to 0, the exponent is equal to 1. And the initial value times 1 is equal to the initial value of the function. So if you have a times b to the power of 0, you're really saying it's to the power of what? Anything to the power of 0 is 1, right? So b would be represented by 1. Therefore, a times 1 is going to be your initial value. Does that make any sense to y'all? Do I need to write that out, or do you understand my verbiage of saying it? In other words, if you had a times b, I got to make sure that, okay, to the power of 0, and this is your function, okay, then if that would mean b to the power of 0 is like saying a times 1, correct? Because whatever b is, anything to the power of 0 is 1. So then a times 1 is just equal to a. And that's what that statement just said. Okay? Everybody clear with that? Okay, so let's turn the page and do a little bit of practice together. It says Carol is investing $15,000 at a rate of 5.5% each year. She used the following formula to help her determine the value of her investment over time. What does the R represent? Growth, because she's investing. So that's an increasing situation. So it's growth, isn't it? Okay? A basketball tournament starts with 256 teams. After each round, half the teams are eliminated. What does the 256 represent in the exponential function for this real world situation? The initial number of teams. Okay? All right. An electric car's battery loses 1/5 of the battery life every hour of use. Wendy writes the function for this situation as f of x is equal to 100 times 0.80 to the power of x. What does 0.80 represent in this situation?
Constant ratio of decay.
Okay, how did we get to that 0.8?
Because we did 1 minus 0.25. 0.20.
Correct, because when you have decay, remember you're going to subtract 1/5 is equal to 0.20, correct? So you're going to subtract your decay, all right? And when you subtract your decay, you actually end up with a number that is less than 1, don't you? And that's how you know it's decay, because the number is less than 1. It would be growth if the number was greater than 1. But you have to subtract. You don't take this 0.2 as here. You have to subtract that from 1, because the formula says 1 plus or minus your R, not just your R in there. Okay? All right, the effectiveness of Tylenol decreases 20% every hour after being ingested. If the initial amount of 400 milligrams is introduced into the body, what is the percent of effectiveness of an hour? Dean says 80%. What do you all say? Why isn't it 0.8%?
Because it's still percentage.
That's correct. That's different than 80%, right? 80% and 20% give you that 1, right? So you're really subtracting 1 minus 0.20, which is 0.80, which written as a percent is 80%. Okay? So that is why that's there. All right, I'm going to hand your papers out, and I want to just go over a couple of them really quickly with you, because a couple of them came up with questions that I think are valid, that I want to make sure and kind of go over and get you started on. You may get it right off the bat, or you may not.
Oh yeah, I still haven't touched my phone. I still haven't done anything.
Carousel. All right. Okay, I believe we came across something, the one thing that I do when I'm doing domain and range, and I know that it has been a struggle for some of you, and some of you are kind of getting better at it. Some of you are still struggling at it. But the one thing I can do here for you is this. There's obviously no restriction here, is there?
No.
On domain. When I see domain, I immediately say, okay, X, and I'm looking at this. Okay? Because that's all I'm concerned about. So I need to know, and since this does not have a real life situation, am I restricted here? So what is it going to be? All real numbers. Okay? Now, what about on number 3? It's looking for range. So I immediately go to here and I go like this because I need range. So I'm looking at how is it affected from here to here. Now, does it have a restriction? Yes, it will always be restricted where? If I am at the parent function, in other words, a times b to the power of x. I don't have a plus or a minus here on the end. That's going to be algebra 2. You're going to have a plus or a minus here on the end, and what that's going to do is that's going to change your y-intercept up or down. Remember how it did it for quadratics? Do you remember that? Okay. Well, it's going to do it for exponentials, but not till algebra 2. So for algebra 1, if it's a parent function, you're never going to cross the x. So you are going to have a range that is always going to be above what? 0 for what? Y or x? Y. Okay, does that make sense to you?
Yes.
All right. Let's look at number 2. And I know I'm doing too many of these, but that's too bad. Sarah deposited $1,000 into a savings account that compounds annually with an interest rate of 7.5% for 10 years. So I'm going to have what type of exponential? An increasing or decreasing? Okay, we are growing, aren't we? Okay, it says what is a reasonable range? So I'm looking for my y here. Okay, my range. Remember the range is going to be determined, and it's going to start with the initial value. What was the initial value? $1,000. So it has to be $1,000, and it has to go up, doesn't it? From 1,000. Now, I could put this in the formula in there and get to a number that's pretty close to how far it can go up to. All right. And if I did that, I would get this. I'm just going to go ahead and do it. If I did that, I would have P, which is 1,000, parentheses, 1 plus 0.075 to the power of 10. And I get this number, 2061. Okay? So I know that in 10 years, it's going to go up to 2061. Now, calculations are probably off a little bit here, all right? But it's not going to get bigger than that in 10 years. So which one of these is going to be your answer? G. It can be between these two numbers. Does that help you out and make sense? Okay? All right. Remember that maybe it'll either be between two numbers in real problem situations, the range, or it will be either lower or higher based on whether this one talks about decay. So it has to be 100, but then the value is going to go down from 100, if that makes any sense. Will it go to 0? No, it will never hit 0, okay? So that's all I have to say for today.
All of this is homework?
All of this is not that much.